In this episode, we'll be talking about practical examples of exothermic and endothermic reactions, and also we will highlight how to represent them on an energy profile or reaction profile diagram. In the previous episode, we discussed what an endothermic reaction is and what an exothermic reaction is. And in case you missed that, an exothermic reaction is the reaction that gives out heat to the surrounding, while an endothermic reaction is the one that absorbs heat from the surrounding. Now, let's just move forward into what we'll be discussing here. And we'll be starting first with endothermic reactions. So an example of that is the reaction between sodium bicarbonate, NaHCO3, solid, and water. So if you dissolve sodium bicarbonate in water, you will form sodium bicarbonate aqueous. So when you perform this reaction, you will observe that the reaction container gets colder or cooler, or the temperature drops. So if you had to represent that on an energy profile diagram, you have something that looks like this. So you have energy, and then the reaction coordinates. Then you have this, like this. So right here, we're gonna have the sodium bicarbonate solid with H2O liquid, and here we'll have the NaHCO3 aqueous. So when you look at the product, which is sodium bicarbonate aqueous, and you compare it to the reactant, which is the sodium bicarbonate solid and liquid water, we have an energy difference. And in this case, this energy difference would be positive because the energy of the product is greater than that for the reactant, so this will be positive. And in case you forget or you missed the previous episode, we said delta E or delta H is equals to delta H of products minus delta H of reactants. And these are just the delta H of formation of product and delta H of formation of reactant. Okay. And another example is with barium hydroxide and ammonium thiocyanate. So it forms ammonia gas with some other products. Okay, so if we want to represent this in an energy profile diagram, we'll have this that looks like this. And right here we will have the barium hydroxide and ammonium thiocyanate. And right here we'll have the ammonia gas. plus other products. Okay, so again, if we compare the energy of the product to the reactant, this will give us a positive energy, right? So these conditions where we have the delta E or delta H to be equals to positive is called endothermic reaction. And the endothermic reaction is not limited to just these two examples. There are numerous other examples of endothermic reactions, but these are just some representative examples. Now let's move to exothermic reactions. For exothermic reaction, the reaction vessel gets warmer, and that is normally sensed as an increase in temperature. An example of that is what we gave in episode 1, which is coal plus oxygen to produce CO2 gas and water. And if we were to represent this on an energy profile diagram, it will look like this. And this is not exact, this is just a schematic representation. So this will be coal, solid plus O2 gas to produce CO2 gas plus H2O gas. And remember that this is energy and this is reaction coordinate. Okay, so if we look at the energy of the product relative to the energy of the reactant, we'll observe that this is product and this is reactant. So this is reactant and this is product rather. We observe that the delta E for this reaction would be negative because the product is at lower energy pedestal compared to the reactant. Okay, so delta E or delta H will be equals to negative. So another example of exothermic reaction is when you react magnesium with oxygen to form magnesium oxide. So you have this like that. So this is more like burning magnesium in oxygen. So you have something that looks like this. We have magnesium solid plus half O2 gas, and then you have magnesium oxide as a product. And this is energy, and this is reaction coordinates again. So if you compare the energy of the reactant, which is magnesium oxide, to which is magnesium and oxygen, to the energy of the product, which is magnesium oxide, you will realize that the delta E for the reaction is negative, right? So this is reactant and this is product. So delta H or delta E is equals to negative. So these two are examples of exothermic reaction. Okay, so key things to remember, just summary. One, endothermic reaction gives cold reaction vessel, and that is because they absorb heat from the surrounding. And the delta H for this reaction is positive. 2. Exothermic reaction gives warm reaction vessel, and that is because they give heat to the surrounding. So, and the delta H for this is negative. So, one is giving heat and the other one is taking heat from the surrounding. If you ever forget which one is which, just remember that endo means internal. So it's taking heat from the surrounding to inside the reaction. Exo means external, so it's taking heat from the surrounding. So it's giving heat to the surrounding, rather. Endo, internal, taking heat in. Exo, external, giving heat out. Okay, and their delta H is for endo is positive and delta H for exo is negative. Okay. Now, if you want me to make video for selected topics, or you have problem with an assignment and you need help, you can send me an email on chemistry knowledge hub at gmail.com. Okay. Also, remember to click the subscribe button so that when I make a video, you can get an update.